questions there. Okay. Hi, I am Bruce Gray, util online. I've been in open source about 25 years. I code mostly in Perl 5 and Raku, but I like all the dynamic languages. This talk has examples in only Perl 5 and Raku because OSCON didn't accept it, but the content really does apply to all languages. This is an incomplete talk based on incomplete research, but it is intended to be two different things depending on how you squint at it. On the one hand, it's an introduction to programming techniques that counterintuitively increase readability. These three techniques, just a taste of each one, how to tell if they're worthwhile for you to learn, and on-ramps if you decide to learn them. Oh, there's a small but cool fourth part after the Q&A. It's only a minute and a half. This talk is also supposed to be an experiment in using refactoring instead of examples to introduce you to the three topics, to try and adapt to their sinkhole nature that has made them under-embraced. Last year, I did a talk on refactoring and readability and how what we think of as maintainability can be addressed by focusing on just readability. Those bold ones are all readability. Since then, I found these sinkholes where coders are not learning techniques that could replace convoluted code with readable, concise code, because at first and second glance, it looks less readable to you because you haven't learned it yet. It looks less readable and you don't see a critical need, so you don't spend the time to learn it. It's the opposite of, ooh, you've got to try this cool new thing. Most famously, regular expressions, or regex. These get a bad rap, partly because they are so associated with Perl, but mostly because they used to look like line noise. They are not Perl specific. They're supported by so many tools and languages. Your editor probably has support for regex search and replace. Regex is in your cheeseburger. This is the famous quote. I don't know how many years ago. Also, they're immediately confusing because they look too similar to the .* syntax that we use to specify files on the command line. That .* syntax is called globbing, by the way. Key symbols have very different meanings in globs versus regex. I will be using ACK in these examples instead of grep. I recommend you use any of these grep replacements. They are faster, smarter about repo structure, and understand the full regex syntax. So I had 700 screenshots from Zoom business meetings. They go to my desktop. I'm on a Mac. They automatically go to the desktop. And I periodically sweep them into folders. And I wanted to know if I swept anything else in with them. I took one of those file names and started changing it into a regex. The digits in the date and time will vary, so I'll need to tell it to look for any digits there, like any digits. And the dots have special meaning in a regex. They mean any character. So I'll have to change them into literal dots somehow. Here we go. Notice that I back-whacked the dot to change it from meaning any character to just mean a literal period. and I will add a $sign at the end. That is an anchor, which means this must be the end of the string. So that is my command. The find will list the files. The ACK will filter that list based on my regex. The -v will invert the filter to show me what doesn't match the regex. And the quotes will keep the shell from messing where it oughtn't. I ran it. Oh, some screenshots were in 2019, but I had left 2020 hard-coded. So I'll fix it. Like that. And run it again. Somewhere in the morning, I had left the PM hard-coded. So I need the P in PM to be A or P. This time for sure. Oh yeah, hours can have 2 digits, but I'm only allowing for a 1-digit hour. Let me quantify. Wait, I'm out of room. Let me resize. Okay, quantify that hour to be between 1 and 2 digits. Is that everything? I don't know, but it was good enough yesterday. Those are all my misfiled files. So I do not now have 2 problems. I have a solved problem. There are great resources online that work for most languages' regexes, like a site to explain a regex, or show what part is matching, or even show you a step-by-step diagram, a state diagram of what it will try to match. Now, this was not really refactoring, more exploratory programming. But this is an important tool, not just for data munging, but because, well, Regex is a microlanguage. You can use it to extract bits of data, sure, but you can also use it to describe what your data looks like and have your program warn you if your data does not match that description in the future. Navigation, extraction, exploration, and validation. Quickly, without regex, to navigate and extract exactly that part of the URL, I need this Perl 5 code. With regex, I need only this. Silent failures and wrong answers are not okay in our programs. Using regex for parsing helps you prevent that. Regex helps you understand your data. For example, parsing the find ls command, this ls flag on find, which some systems, that's the only thing I can run, and it's not GNU find. So you may be thinking, this is a space-separated format. Just split on white space. There's no need for regex. Okay, let's do that. Simple. Wait. File names can contain spaces. This one has 2 double spaces. So we put a limit on the split. But that first number, the inode, sometimes has spaces in front of it. That throws off every field. So we could split to an array throw away the first field if it's empty and then assign. No, we can't do that. We only split 9 fields, so path will be empty. So instead, we have to resplit. Good grief. Let's just trim the leading white space and go back to a plain split. But we're not done parsing. The next to the last field, mod time, it contains hours and minutes only for newish files. Older files get the modification year, which I'd never really noticed until doing this parsing. So we need code to handle that. So that's not awful, but it's more than the simple split we thought would work. And it actually uses regex twice. And it breaks again when the source system allows spaces in the group name. But put such horrors out of your mind. What would the regex look like? This is the first of 2 regex I use for the parsing. It parses just the modification month, day, and year or time. The complex part. For the year or time, we describe the time as hour, minutes. The year as any 4 digits preceded by a space. And we say that the data can be either of those 2 with a parenthesis and vertical bar. And the regex engine just figures out what it needs to do there. I build up the main regex with a reference to that prior regex. And with the named captures, instead of referring to size as the 1, 2, 3, 4, 5, 6, 7th capture, I can refer to it as size and use it like this. Now, this is all quite readable. It is, but only once you've learned regex. I made a Reiku version of this. I think it's even better. By the way, these regex solutions, whether Reiku or Perl 5, well, they also break like the earlier code did, the split code. They break on the files from the evil system with the spaces in the group name. But it's easy to make regex fail loudly. The version that split on space, if you're asking questions involving file size, you are just going to get wrong answers. Its failures are hard to detect and hard to debug. With regex, Perl can pinpoint the failure for you. By the way, I had finished writing this presentation and was adding images, like the famous book that covers regex in so many languages. I had had it for years and never noticed this. Regex will be frustrating, much like when you first learned to program. I hope this refactoring by replacement will help you decide if regex are worth your time. Here are some good starting points. Next section. Multidimensional data structures, also called nested or multi-level or deep data structures. Now, simple data structures you should already be familiar with, arrays and hashes. Your language may have different names or specialized forms, but really it's just these 2, array versus hash, ordered versus unordered, indexed by position versus indexed by key. When the values in those arrays are hashes, the values are just numbers or strings, then they're simple or single dimensional. But the values could instead be whole other anonymous free-floating hashes or arrays. In Perl, we might talk about an AOA, array of arrays. I showed this slide 10 years ago to the Atlanta Perl mongers. It was in a different talk. And they read that last line. I got some pushback. So I came up with this for a 4-level array of hashes of arrays example. A hospital has multiple numbered floors, each with multiple wards per floor, with multiple nurses per ward, with a list of patients in room number order. So if my wife Sarah was working on the med-surg unit on the 3rd floor and I wanted to know the 5th patient she would see, I can directly jump to them. Now, I don't want to start that deep, so we'll play with the simplest of the data structure code smells, parallel arrays. If I have a file of tab-separated name, address, city, and I'm writing code to load and munge those records, then I have options for how to store that data in my program. If we have read the data into parallel arrays, sorry about that. If we've read the data into parallel arrays so that all the names are in one array variable, all the addresses are in a different array variable, and the cities likewise, then just accessing the data is not too bad in readability, but it is error prone. You add a field to your program, and somewhere in all the places you reference it, you'll forget to add that array to the code. It would still be readable if we were deleting all the Hermans, but a bit scarier. The arrays are all out of sync during the deletion and back in sync at the end. Hopefully no one will add debugging code in between 2 of those splices and get confused by misaligned data. Certainly no one would call a function, right? I wouldn't actually write it like that. Too easy to forget the reverse and skip over a Herman. I might write this, better to me, but I write a lot in functional style, so your mileage may vary. By the way, that does work. I keep getting questions about it. It's worked since Perl 5.12. Okay, what if instead of the parallel arrays, we used an array of hashes? So instead of a name array, we have a name key in each hash, and so on. Then our Herman squashing code goes from this to this. Concise, less to read, more readable, and a lot less that the maintenance programmer can get wrong at 2 in the morning. Imagine if it was 30 fields. This gets huge. This stays the same size. I'm actually spoiled by Reiku, where I don't have to repeat the name of the array. I have seen code that would join all the fields back together, filter based on the entire joined line, and then break them back apart. because of parallel arrays. If you do that, it would remove people from the city of Herman too. It's a bad code smell. But they keep being coded because of lack of comfort with arrays of hashes. Let's quickly go 2 levels deeper with a completely made up example. If you were chaotically rereading the Harry Potter books and the best of their fan fiction, you might jot down a happy little note every time a character had a crowning moment of awesome. If you were flitting from story to story like a hummingbird with ADD, your notes might look like this. Harry's internal critic promptly awarded him the all-time award for the worst acting in the history of ever. Okay, some of them are more funny than awesome. Anyway, I want to make a summary, 1 line per crowning moment of awesome, but clustered by book and by character. It would look like this. So input format is multiple lines per moment. And output format is 1 line per moment. Please take 15 seconds to think about either how you would solve this or where you would even start. Two days ago, I described all this to my wife, and she said, first, I've never heard of a crowning moment of awesome. That's great. And second, this sounds like a database. And she's right. It is vaguely shaped like a database. If you've written SQL, this might have come to mind. I have seen Perl code that writes the data to SQLite, not for future use, but just to run a grouping calculation on it and get the result. It's like writing out a flat file and calling the system sort because you don't know how to use Perl's built-in sort. Now, there are several reasons a database is a bad fit this time, but the main reason is you don't need to. We said the summary should be by book, by character. So that's a hash of hashes. The rest of the data are lists that need to be kept in order. That means a hash of hashes of arrays of arrays. So this is easily solved in any language that has dynamic hashes and arrays, which I think is all the dynamic languages. Now this is a shorthand to describe such a structure. When you are crafting deep data structures ad hoc so that they only exist in the lifetime of your program, please put such a line in a comment. You will have the thanks of your maintenance programmer, who is probably also you. Now, I will show you working code, but it will be quick because this is an intro, not a tutorial. But first, I want you to know I'm not trying to sell you on this exact solution. If you write tons of SQL and very little Perl, maybe you should lean on your most familiar tool. Maybe it's Excel. I am suggesting that you become fluent in solving this kind of problem. Fluent like you see it and you know exactly how to solve it. Because that fluency will change your perceptions. It's the kind of change that lets you level up. to shift away from being a report writer or a priest of the machine and towards being a partner with your IT consumers. The fundamental question is always, what should we be doing? But they don't always know what to ask next. You can help shape those questions. Okay, that covers the thinking half of data structures. The other half of the trouble is syntax. In Perl 5, the sigils change based on usage. You have to wrap it in sigiled braces when you need the whole hash of the whole array instead of one element. It's not easy to learn. It's downright hard to remember. The old syntax is a speed bump. 4 years ago, Perl 5 added improved syntax. Use it unless you have to support older Perls. Reku has a much more consistent syntax. In any of the three, or in any of the other dynamic languages, I find the results to be well worth the trouble. I cut my other inspirational speech here for time. Here are the starting points. That brings us to trees. Wait a minute. Why is this a separate section when a tree is a deep data structure? Well, all the data structures we saw earlier were dynamic in content, but had fixed shape. If we coded a hash of hashes of arrays, then that second level is always a hash, no matter what data was fed in. There won't be an array there because we didn't code to create one. You could, it's more complex, but the shape is determined by your code. We coded for fixed shapes. With trees, the data will change the shape. I'm putting on my computer sciencey hat for this one slide. Typical characteristics of trees. Instead of hashes and arrays, everything is a node, which is an object pointing to and containing other objects. Those containments and pointers all have direction, not just we are related. That would be undirected. I am his father. He is my son. That's direction. Hierarchy. A parent can have 0, 1, or many children. Here in the tree, you can only have one parent. Order. I was born first. My brother was born second. There is an ordering, even to nodes at the same level of the hierarchy. Navigation. Each object has methods you can call to get its parent, its siblings, children, and its own properties, which we call attributes. That's horrible. It's demotivational, too abstract. Trees are really simple. You might do unsimple things with them, but trees are simple. Here's a familiar point of reference. Simple HTML. Can we agree that this is the same as this? All we've done is change the white space to indent to better show what is inside a pair of tags. Can we agree that this is the same as this? You can't feed it into a browser anymore, but you can recreate the first or second one from the third, so they contain the same information. It's just like Python style. This also contains the same information, an ASCII drawing of the tree that the HTML was in the first place. We could make that tree pretty. It would still be the same information. This mental transform is the second hurdle. The first hurdle is the computer science nature of a lot of the literature. Scariness. The alienness of thinking that these are the same thing, that goes away with practice. Let's handle some real HTML. I am currently quarantined in a quiet neighborhood in Alabama in the summer. When it gets windy, I want to know so I can go play outside. From the Weather Underground, I just need this bit. So first thing, what do we do first thing? Grab a copy so we don't hammer their server while we're figuring out the parsing. Okay, the HTML for just this part of the page, after I tidied it, is this, which is not perfect, but hopefully that won't matter. I just need all the text elements in this div block, the div block that has class condition wind. I think that everyone who first faces HTML or XML, if they know Regex, they try Regex, even though we say everywhere to not do that. So let's do that. And without deep wizardry, we cannot just say, go to the close div that matches the condition wind div. Because to a regex, one div in tag is just like any other div in tag. So we have to cheat. We count the number of closing div tags to find the endpoint. And so our solution is instantly very fragile. It'll break if they even clean up those empty div tags. We throw away everything that is not between the target div tag and the 6th closed div tag after it. That's a pause for everybody to shudder. That regex has some challenging subtleties in it. It's not beginner level. Change every tag to a space, clean up non-breaking spaces, squash series of spaces into single spaces, trim leading and trailing white space, and output the result. It works, but it's fragile and hard to write. It took me 20 minutes. The Reiku version is nicer, but it's just as fragile because regex is the wrong tool. You should at least use a parser. There are several good parsers. I like this one. It presents the HTML as a stream of tokens. Now this weirdly formatted but totally valid HTML. Toke parser will iterate over its tokens. That is all one token, even spread out among lines. It's a start tag. All that text is a single text token. That token is an end tag, so 3 tokens. The parser will normalize them for us as we go. This is all setup and tracking code. The important stuff's on the next slide. But I won't go into this next slide because right after I perfected it, I realized it would be shorter and faster to do it with 2 loops. In the first loop, we loop through the tokens, and when we see a start of a div that has a class of condition wind, we leave the loop. So the second loop will start at that point, like all the tokens before that had never existed. Then on each start tag, we count up a level. On each end tag, we count down a level and leave the loop if we drop below the level we started. In the meantime, scoop up all the text tokens. Not remotely as fragile as the Regex version, and it's even faster. But I think your maintenance programmer will need this to be documented, heavily documented, and have the docs to the token parser module in hand to work on this. What if, instead of treating this as a string of tokens, we treat it as a tree? We can use the HTML tree builder module. And yes, there's an XML tree builder module too. We create a new tree from the HTML in the file, view from file. It builds the whole tree in memory in that one statement. To get the wind subtree, we ask the tree to look through all its descendants and give us the first node that it comes to that is a div tag and has a class that starts with condition wind. From that wind subtree, we can ask it for the text of all its descendants, all run together, the space between them, while also fixing that non-breaking space. And that's all. We only needed 2 requests of the tree. Trees are only scary in the same way sorting is scary. In college, when you have to write your own implementation, it's hard to get it right, and it's hell to debug. But in the real world, you call someone else's implementation and just feed it your code for specific behavior. The downside is speed. The regex was 11 times as fast. The token parser is 55 times faster than this. But this runs in 1/4 of a second, so I don't care. This one took much less time to write, and it's easy to read and maintain. Optimized for programmer time, not machine time. Now, just like patterns of navigation, navigating a string can get huge, like the slide I showed you earlier in regex of here's what you have to do to get this part of the URL, got huge. Regex is a microlanguage that does that. It's optimized for that. It's built for that. Designed for it. That's the word. So I want you to know that if you're writing a lot of intricate tree navigating code, the stuff we were just doing, there's a microlanguage for that called XPath. It's not a Perl thing. It's widely supported. And similarly, for navigating complex JSON, if your code gets too unwieldy, you can abbreviate it using the microlanguage, either the external utility JQ, JSON query, it's a great tool, or the module JSON path. JSON path's also a standard. It's newer, but lots of languages support it. Oh, it turns out you don't really have to scrape the weather underground. Weather.gov has a real API. Now, before the awesome ending, what questions do you have? You have 7 minutes for Q&A. And I'm not sure how to do this, but I think.
Okay, I see Ben has a question.
Yeah, just real brief, and as you went over the regex, is just looking at some of the modifiers there. If you have any recommendations, insights, general musings on the use of any particular modifiers.
Yes, I just since the book came out, I've been following the Perl best practices from Damien's book, and basically put MSX on everything. In fact, there's even I think a module or a pragma to automatically turn that on for every regex lexically in your code, because it takes the stuff that's confusing or inconsistent about whether dot means any character but new line, and what the beginning and end lines mean, and straightens them out. I may have missed using \A and \Z instead of caret and $sign in that example, but that's always my go-to, unless it's just like, you know, a 5-character regex is MSX.
All right, thank you.
You're welcome. What else? I took a course from Damien on presentation one time. One thing he stressed is, don't ask what questions do you have, and then pause 10 seconds and say, okay, bye. People need time to get their heads around whatever you've just crammed in there. So I don't mind waiting for you to form questions.
Wait, am I live? Okay. So I don't know, maybe this is a bit of a silly question, but thinking about trees, like if you say you had to implement a tree just using like basic Perl data structures, what do you think would be the best way to do that? I assume probably like some like level of nested hash references or something, but or would that just be a sign that you need to pick a different language if you find yourself doing that?
No, not at all. I find that my go-to module is called tree : DAG _ node. A DAG is a thing. It's directed to acyclical graph, computer science, but it's just a general purpose. Most of the stuff you want to do with the tree, it has built in. Every node is an object, so you're not having to worry about the shape in your code. You can let your data dictate the shape, and it provides all the navigation stuff that you need. And I believe that there's an extension to it for tree : DAG node : XPath if you want, you know, rapid navigation through it. But it's every language has a general purpose tree module that I know of, and I would always go with that if I knew that the data was going to be in a tree. Having said that, if you really want to do this without objects and using primitive, using hashes, arrays, that kind of thing, there's Data Walker and a couple of other, maybe DPath, are modules that let you specify without a fixed form how to navigate your data. So, you know, like instead of having 3 places that you have to put a key, and a key, it'll say from the current place you are, make this action. And so if you're trying to do it the hard way, it will make it a little easier. That's probably all I have time to go into on this. Did that help?
Yeah, it did. Thank you.
You're welcome. And could I know who's speaking, please?
I'm Cameron Tokes.
Thank you. I don't quite know how to navigate what I'm looking at.
It looks like we have another question from Ben Kaufman.
Go ahead. Looks like you're muted. Maybe his hand went up and I sent a ask to unmute. And
Am I unmuted? I thought I was.
there you go. We can hear
I'm sorry. Yeah, I thought I had already unmuted. No, I think you addressed a lot of it with the question Cameron had asked. Just looking at, you know, you're using HTML tree builder and the look down method, which is not documented directly in that. In other words, you'd follow the reference to HTML tree, and then from there to HTML tree, or what's the it was a little bit of a find to get to that particular method.
Yeah, and that's unfortunate. There is a sort of overarching HTML-tree document that describes HTML element and tree builder and all that. It ought to be in tree builder because that's where you're looking for it. But please go ahead.
No, and that was just you touched on some other modules there, which was, I think, just really kind of where I was going. So I don't have anything more on that then.
Score.
Yeah, thank you.
Already answered. And my wife says it's time for the bonus part. So I'd love to see your questions on email or in chat. Whoa. There it is. Here's the bonus. Once you have a firm grasp on these three tools, you are standing at the doorstep of a new world called static analysis. The modern code analyzers, linters, critiques on code quality, like Perl Critic, and security scanners, these all work by static analysis. The three techniques we just covered, plus the documentation for your language's parser toolkit, PPI for Perl, that's what it takes to be able to contribute to these projects, or to write rule sets, your own rule sets, so these work better for your team's code base. We need more of these kinds of tools. And finally, if you get that far, I hope you'll take the next step in your language, as I'm trying to do in Perl, and write programs to automatically refactor and rewrite code. Something that takes your Perl 5 program and produces code that's mostly converted to Reiku with a report of what a human needs to decide on. Or that gives you even better Perl 5, a modernizer. And I tell you, whatever tool converts your Perl 5 code to Perl 8, Sawyer mentioned that after Perl 7, I bet that tool will be driven by static analysis.